Welcome to the Deep Dive, where we take a stack of sources and extract the most important nuggets of knowledge to get you well-informed, fast.
That's the goal.
Today, we're plunging into a world many of us spend countless hours exploring, interacting with, and sometimes even, well, living in, but rarely stop to consider the monumental undertaking behind it. Video games.
Absolutely. Behind every immersive world, every thrilling challenge, every captivating story,
Yeah.
there's just this incredible amount of creativity, tech mastery, and really intricate planning.
Totally. You might spend hours navigating a digital landscape, mastering a new ability, but have you ever truly stopped to think about what actually goes into making it?
It's true. What appears on screen as like seamless entertainment is in reality the culmination of countless decisions and a massive collaborative effort across an astounding array of disciplines.
Right.
It's a fascinating blend of art and science, and it's far more complex than just writing some code or sketching a few characters, much more.
Absolutely. So, our mission for this deep dive is to give you a shortcut, basically, to understanding this multifaceted world of game development. We want to reveal surprising facts, connect the dots, so you can really appreciate the true artistry and engineering behind your favorite digital experiences.
Yeah, pull back the curtain a bit.
Exactly. To guide us, we've pulled together an incredible stack of sources. We'll be drawing insights from Comparing Popular Game Engines by PubNub, a really comprehensive legal guide to the game industry, from Trinity Jurex, The Complete Guide to Game UX by iCreatives.
And deep dives into video game development from Wikipedia, plus some great real-world insights from Reddit's game dev communities on like what software they actually use day to day, how they manage projects.
It's a great mix.
We're going to unpack everything from the fundamental tools developers use, the crucial legal frameworks that protect creators and players, and even get into the booming world of esports.
All right, let's dive in. Let's begin at the very foundation, okay? Building any video game means choosing your tools, specifically game engines and development software.
Right.
If you've ever even thought about making a game, or even just read about it, you've undoubtedly heard the term game engine thrown around. But what exactly is it, and why is it so critical?
Okay, so a game engine is essentially the crucial software framework. It provides the core functionality for game development. Think of it as the scaffolding, maybe, or the skeleton upon which an entire game is built.
A skeleton, I like that.
Yeah. It handles everything from rendering graphics, simulating physics, processing player input, even managing sound, all that foundational stuff.
So without an engine, you'd have to build all that from scratch, every time.
Exactly. Every single one of those systems from the ground up for
Yeah.
every new game, which would be, well, unimaginable, almost impossible, really.
Okay, that makes incredible sense. It's like having a fully equipped, specialized workshop versus just a pile of raw materials and having to, I don't know, forge all your own hammers first.
That's a great analogy, yeah.
So given all the options out there, what factors do developers really consider when picking their engine? I imagine it's certainly not a one-size-fits-all kind of deal.
No, definitely not. PubNub's comparison really highlights this. Key factors include the initial cost, obviously. That can range from completely free, like Godot, to subscription models, or even royalty-based payments once a game starts making money.
Right, the business model.
Then there's the learning curve. Some engines are just much more intuitive for beginners to pick up than others. Community support is absolutely vital too, for troubleshooting, finding answers, tutorials.
Can't underestimate a good community forum.
Never. Developers also weigh the specific features offered, of course. Does it have what they need for their specific game? And critically, platform compatibility. Does it support mobile, PC console, .VR?
Makes sense. You need to know where your game can actually run.
Precisely. And the real insight here, I think, is that for developers, picking an engine isn't just about the features today. It's a long-term strategic decision. Committing to one means investing heavily in its ecosystem, its workflow, learning its quirks.
So it shapes their future projects, too.
Absolutely. It's a critical choice that can shape a studio's entire future output. It's a big deal.
That's a lot to weigh. Definitely a strategic choice.
Yeah.
Okay, let's compare some of the big players that PubNub talks about, starting with, well, the undisputed behemoth, Unreal Engine.
Right. Unreal Engine. Developed by Epic Games, it's really renowned for its cutting-edge graphics, that high-fidelity visual look. It's often the go-to choice for many AAA game developers, the big studios aiming for photorealism.
So when you see those incredibly realistic games.
Yeah. Games like Fortnite, obviously, Gears of War, Street Fighter V, you're often looking at the power of Unreal. Its pros include this incredibly robust toolset for pretty much everything: animation, complex physics, visual scripting with blueprints.
Blueprints of the visual scripting, right? Less code heavy.
Exactly. It makes some things more accessible. It also has a vast and active community, tons of resources online, and it's highly scalable, works for projects from, smaller indies all the way up to massive blockbusters. Plus, it's always pushing the envelope, supporting next-gen tech like real-time ray tracing.
And I've heard it can be a bit daunting
Yeah.
for new developers.
Hmm.
Almost like trying to learn rocket science, someone said.
You're perceptive, yeah. That reputation isn't totally unfounded. Its primary programming language is C++,
Ah, C++ or.
which, yeah, contributes to a steeper learning curve compared to some other options. C++ gives developers immense control, like direct memory management, really fine-grained power over system resources.
But that comes at a cost.
It does. The
Yeah.
cost is complexity. It can indeed be quite intimidating for beginners. So while it's incredibly powerful, it demands a significant time investment to really master it.
Okay, then we have Unity, which seems to be absolutely everywhere, especially dominating the indie scene, maybe.
Unity is remarkably versatile and generally seen as more user-friendly. That makes it super popular with both indie devs and larger studios too, actually. It excels at developing 2D, 3D, AR, VR games. It's a real workhorse.
I'm an all-rounder.
Definitely. It boasts a pretty intuitive interface and this massive asset store. That's a huge plus. Developers can just buy pre-made models, scripts, tools, sound effects. Speeds things up immensely.
I bet. Saves reinventing the wheel constantly.
Exactly. And that statistic is striking. Over 50% of all games on Steam are apparently made with Unity. Think about the range of titles: Cuphead, Pokemon Go, Beat Saber, Hearthstone, Escape from Tarkov, Hollow Knight. Totally different games, all Unity.
That's incredible diversity. What's its main language?
Its primary language is C#, which is generally considered more user-friendly and modern than C++. It manages memory automatically, garbage collection, and all that, which frees developers to focus more on the game logic itself.
Less low-level fiddling.
Pretty much. And it has excellent cross-platform support. You develop once, and you can deploy it across mobile, PC, consoles, VR. That's a huge advantage for reaching wider audiences.
So Unity seems like the accessible all-rounder. But does that accessibility ever limit its potential for, say, those truly groundbreaking visuals that Unreal is famous for? Or do they just occupy different niches?
That's a good question. While Unity is capable of producing really beautiful games, its graphical fidelity doesn't quite match Unreal Engine for the absolute highest-end, cutting-edge AAA projects that are chasing pure photorealism.
So there's still a gap at the very top end.
Generally speaking, yes. They do tend to occupy slightly different niches, or at least have different primary strengths. Unity for broad versatility, rapid prototyping, incredible cross-platform reach, and ease of entry. Unreal for that unparalleled visual fidelity and handling massive, graphically intensive productions.
But for versatility and just getting started, Unity sounds hard to beat.
It really is, yeah.
Okay, next up we have Godot. This one's getting a lot of buzz, especially because it's open source.
Godot is definitely gaining significant traction, yeah. Particularly with indie developers. The big draw: it's completely free to use, no royalties, no licensing fees, no hidden costs, ever.
Wow, that's huge for indies.
It's a massive advantage if you're on a tight budget. It supports multiple programming languages too, its own lightweight GDScript, which is Python-like and pretty easy to learn, but also C# and C++ plays. And Visual Script for node-based coding.
Options are good.
Definitely. It's also very lightweight and efficient, which makes it suitable for smaller projects or games targeting lower-end hardware. And it uniquely offers dedicated 2D and 3D rendering pipelines, optimized for each.
Oh, interesting. So it treats 2D as a first-class citizen, not an afterthought.
Exactly, which is a big plus for 2D developers. Its community, while smaller than Unity's or Unreal's, is very active, really passionate, and growing rapidly, and it offers solid cross-platform export capabilities too.
Sounds like a dream for an indie dev on a shoestring budget.
Yeah.
What are the catches, the downsides?
Well, its main limitations kind of stem from its relative youth compared to the established giants. The community and the asset marketplace are still smaller. That means fewer ready-made resources, fewer tutorials maybe, potentially less immediate support compared to the massive ecosystems of Unity and Unreal.
So more DIY required sometimes.
Potentially, yeah. And while it's powerful, it's generally considered less feature-rich out of the box for very large-scale, complex 3D projects compared to Unreal Engine. It also has less widespread industry adoption, which might mean fewer easily integrated third-party services or tools. Developers might have to do more manual integration work.
Okay, that makes sense. Trade-offs, as always.
Always.
And finally, rounding out our engine comparison, we have Game Maker Studio.
Right, Game Maker Studio. This one's specifically optimized for 2D game development. It's known for being one of the most accessible engines for absolute beginners, largely thanks to its intuitive drag-and-drop interface.
Drag and drop, so less coding required initially.
You can get quite far with just the drag-and-drop system, yeah. But it also uses its own scripting language, Game Maker Language, or GML. It's a simplified proprietary language designed specifically for ease of use in making games.
Proprietary, huh?
Yeah, that's a key point. It also boasts an active community, good cross-platform export, and it makes managing game resources pretty straightforward.
So it sounds ideal for someone just starting out, maybe wanting to build a retro-style platformer or a top-down shooter in 2D.
Exactly that kind of thing. But its 3D capabilities are extremely limited. It's really a 2D engine first and foremost. And because GML is proprietary,
The skills don't transfer as well.
precisely, the skills learned within Game Maker Studio aren't as directly transferable to other engines like Unity or Unreal that use more standard languages like C# or C++Y. And it can be more challenging to integrate external SDKs or APIs because of that proprietary nature.
Right. So great for starting in 2D, but maybe less flexible if you want to branch out later.
That's a fair summary, I think.
Okay, so it's clear that while the game engine is foundational, it's definitely not the only piece of software developers need. Game development requires a whole suite of specialized tools for assets, animation, sound, everything.
Absolutely, yeah.
What are some of the popular choices in these areas?
Yeah.
Especially for 2D games, which often have unique requirements for things like pixel art or really fluid character movement.
You're absolutely right. Beyond the engine, you need tools for creating characters, environments, UI elements, sound effects, music, everything the player sees and hears. For 2D asset creation, particularly the visual art, developers on Reddit's game dev communities often highlight a few key programs.
What are they seeing as the go-to tools?
Well, Esprite is widely considered the gold standard for pixel art. If you're doing that specific retro style, Esprite has specialized tools that make it much easier.
Okay, king of pixel art. What about more general drawing?
For general drawing and painting, Krita is really popular, especially because it's free and open source. Great features. Though some users report occasional minor issues with, like, tablet detection, and it might lack certain advanced layer effects you'd find in commercial software.
But free's a big plus.
Huge plus. Then there's Adobe Photoshop. Still a common choice, particularly in professional settings. It has great scripting support, tons of features, and the .psd format is widely compatible.
Oh, wow, but the subscription.
The subscription model, yeah. That can be a turnoff for smaller teams or solo developers. It adds up.
Makes sense. And what about animation? Especially with those clever skeleton systems I've seen mentioned. This sounds like where truly dynamic 2D characters really come to life.
Yeah, this is where clever design really shines, and where you can save a ton of work. Traditional frame-by-frame animation where you literally draw every single pose.
Like old cartoons.
Exactly. It can be incredibly time-consuming, especially for complex characters with lots of movement. Using a skeleton or bone-based animation is often much more efficient.
How does that work exactly?
Well, instead of drawing every frame, you draw the individual parts of a character, an arm, a leg, a torso, maybe different hand shapes. Then you attach these parts to a digital skeleton, like rigging a puppet.
Okay.
You then animate the bones of the skeleton, and the attached parts move naturally along with them. It's like digital puppetry.
Ah, I see. So it allows for much more fluid and efficient movement and easier modification.
Absolutely. And reuse. You can create one walk cycle animation, for example, and apply it easily. Which software is leading the pack here for 2D skeletal animation?
Yeah, what are the top tools for that?
Spine is widely considered the best dedicated skeleton animation software for 2D. It offers really robust integrations with multiple engines, Unity, Unreal, Godot, so your animations port over smoothly.
That integration is key.
Critical. Spine boasts powerful features like mesh deformation. This lets you bend and warp the 2D images attached to the bones, which can create this almost 3D look, sometimes called a live 2D effect, really dynamic.
Adds a lot of life without needing actual 3D models. What's the cost like?
A single pro license is a one-time cost, around $369 last I checked, which, for professional software is pretty reasonable. A solid long-term investment for serious 2D animation.
Okay, and I've heard Blender mentioned, which is surprising because it's mainly known for 3D modeling and animation.
Huh?
How does Blender fit into 2D?
That's a fantastic point, and it really speaks to Blender's incredible flexibility. It's free, it's open source, and developers can use its unique grease pencil feature for vector drawing and 2D rigging.
Grease pencil.
Yeah, it lets artists draw directly in 2D within Blender's 3D space. Then they can use Blender's powerful bone-based animation system for those 2D characters, just like they would for a 3D model.
So you can rig 2D drawings in Blender.
Exactly. What's particularly cool is you can also mix in 3D elements seamlessly, draw directly on top of 3D meshes, even import external 2D art and rig it within Blender.
Wow, that sounds incredibly versatile.
It is. It's a powerful option for developers who want to, say, customize characters, easily change colors, add accessories, and apply complex animations without redrawing everything. You could even blend 2D characters with 3D environments or effects.
So even for something like, I don't know, a simple stick figure character that needs different colored outfits and lots of actions, Blender could handle that surprisingly well.
Absolutely. The ability to swap parts, customize colors, add accessories, and apply various animations is very doable with bone-based systems. It allows for that modular character design.
Are there other options besides spine in Blender?
Yeah, a few others get mentioned. Godot actually has its own built-in 2D bone system, though some users feel it's maybe less feature-rich than dedicated software like Spine. Dragon Bones is another free alternative, often compared to Spine, and even professional vector tools like Adobe Illustrator have been used for 2D rigs in games like Night in the Woods, showing there's a range of approaches.
It really highlights how the choice of software isn't just about features, is it? It's deeply tied to the project's specific needs. The desired art style, pixel art, vector, hand-drawn on the budget, of course, and just what the team already knows and feels comfortable with.
Exactly. Team familiarity is a huge factor you can't ignore. Learning new, complex software mid-project is rarely a good idea.
Okay, so once the foundational tools are selected and the dev team is busy actually building the game's world and mechanics, there's another absolutely critical component. It often goes unseen by players, but it profoundly affects how the game feels to play. Let's talk about game UX design.
Ah, yes, user experience. Crucial stuff.
It's not just about making a game look good, right?
Yeah.
It's deeper than that.
Much deeper. When we talk about user experience, or UX, in games, it's useful to first distinguish it from UI, user interface, and also from general UX in other fields.
Okay, break that down. UI versus UX.
Right. User interface, UI design, focuses primarily on the aesthetics and the visuals, things like button layouts, icons, color palettes, typography, how it looks and how the visual elements are arranged for clarity.
The surface layer, the visuals.
Exactly. General UX, broadly speaking, concerns how a user feels about any product or system. Is a website intuitive? Is a banking app efficient? Is a self-checkout machine satisfying to use? Or frustrating?
So the overall feeling and usability.
Precisely. Now, game UX is the entire experience a player has with a video game. This encompasses everything. The interface, yes, but also the core gameplay mechanics, the controls, the audio cues, the visual feedback, the difficulty curve, the progression systems, the story delivery, all of
The
it.
whole package.
The whole package. The overarching goal of game UX is to make the game as enjoyable, engaging, and ultimately as satisfying as possible, to keep players immersed, motivated, and coming back for more.
Okay, that sounds like a pretty standard UX goal, make it pleasant, make it easy to use. But here's the fascinating twist with games, right? There's this crucial aha moment that completely reframes how we think about player experience in gaming. What is that fundamental difference?
Okay, here's the core distinction, and it's really important. Traditional UX design and pretty much any other industry think, websites, apps, software tools, aims to remove challenges and friction for the user.
Right, make it smooth, effortless.
Exactly. You want those experiences to be as seamless and intuitive as possible. Zero frustration is the goal. Game UX, however, deliberately builds challenges. It creates friction for players to surmount.
It adds friction. On purpose.
On purpose. Game designers want you to struggle a bit, to overcome obstacles, to solve puzzles, to figure out mechanics, to defeat tough enemies. The satisfaction in games comes largely from conquering that friction, from mastering the challenge.
That's truly fascinating. It's not about making it frictionless, but about designing the right kind of friction.
Yeah.
The kind that feels rewarding to overcome.
You've nailed it, the right kind of friction. And that raises the critical question: how do designers prevent that right kind of friction from just becoming, well, tedious? or unfair, because if it's just frustrating, players will just quit.
Right.
Yeah.
Exactly. There's a fine line between challenging and just annoying.
There is, and that's the art and science of it. It's where the iterative process becomes absolutely essential. Game UX design isn't a one-shot deal. It's a comprehensive, continuous loop.
A loop. How so?
It involves constant prototyping, creating quick, playable versions of features or mechanics, then testing them extensively with real potential users, and then rigorously analyzing their feedback and behavior and adjusting the designs based on what you learn.
So build, test, learn, repeat.
Exactly. This ongoing cycle ensures that the game improves over time. You're constantly tuning, finding that sweet spot where challenges feel stimulating, not just punishing, and the reward for overcoming them feels genuinely earned and satisfying. It's a very delicate balancing act.
So it's never a one-and-done process. It's this cycle of creation, testing, feedback, and refinement that constantly molds the player's experience throughout development. Can you walk us through the typical stages of game UX design? How does this cycle actually unfold in practice?
Sure. While specific teams might adapt their exact processes, the core stages are generally pretty consistent and, importantly, interconnected. It usually begins with research and planning.
Understanding the player first.
Exactly. This initial stage is all about deeply understanding the target audience. Who are we making this game for? What are their needs, motivations, gaming habits, expectations? This research helps determine the game's core features, mechanics, difficulty level, and overall objectives. You need that foundation.
Makes complete sense. You can't design effectively in a vacuum. What's next after the research?
Then comes conception and ideation. This is the brainstorming phase. Here, crucial details like the game's storyline, core gameplay loops, control schemes, reward systems, and overall structure are fleshed out. Following this, initial prototypes are often assembled.
Prototypes, right? We talked about those.
Yeah, and in UX, they might be simple paper prototypes just to test flow, or rough digital mock-ups to quickly test core interactions and mechanics without building the whole system yet.
So you've got the idea, you've brainstormed, now it's time to start bringing those concepts into a more tangible form.
Precisely. The third stage is design and production. This is where the actual game interface elements, menus, HUDs, icons, along with sound design, graphics related to UX, and other components are actually developed. This involves creating detailed design documents, often including wireframes.
Wireframes, like blueprints for screens.
Kind of, yeah. Skeletal outlines showing the layout and flow of game screens and interfaces without all the final art. This stage also involves the actual coding and initial internal testing of these systems to make sure they function.
And after that, I imagine it's straight into getting real player feedback.
Yeah.
Bringing in that outside perspective is key, right?
Yes, absolutely critical. That leads into testing and iteration, perhaps the most crucial stage for UX. You get a carefully selected sample of your target users to playtest a prototype of the game. This could be in a controlled lab setting, watching them play, or through distributed beta tests.
And you just watch and learn.
You watch, you record, you ask questions. Feedback and behavioral data are compiled. Where did they get stuck? What did they find confusing? What felt rewarding? Based on this feedback, the prototype is refined, improved, and then you test again. This process repeats, iterating towards a polished, intuitive experience.
What kind of feedback channels do they use?
Oh, lots. Structured interviews, player surveys, analyzing online forums and social media for comments, and of course, direct user testing sessions, maybe with eye tracking. If multiple players highlight the same usability issue or consistently struggle with a particular mechanic, that's a very clear signal that something needs refinement. Actionable feedback.
So it's very much like a continuous scientific experiment with player enjoyment and engagement as the central hypothesis you're testing and refining. And finally, the big moment, launch.
The final stage is indeed launch and post-launch. The game is released to the public, accompanied by marketing and promotion. But a game UX designer's job doesn't just stop there. Not at all.
It continues after release.
Oh, yes. They continue working on updates and improvements based on ongoing user feedback from the live game, analyzing player data, telemetry, and providing continuous support and maintenance. Good games evolve after release, often based heavily on UX insights.
It sounds like the game UX designer is truly the player's advocate throughout the entire journey, always bringing that user perspective to the table, maybe when the rest of the team is focused on technical details or artistic vision.
They really are the player's voice, yes. Relentlessly ensuring clarity in the game's rules, mechanics, controls, and feedback systems. They have to constantly put themselves in the shoes of a novice gamer, someone seeing this for the first time. They spot the things that the developers, who are often, too deep in the complexities, might inadvertently overlook.
Like the curse of knowledge.
Exactly. A major focus for them, especially early in the game, is ensuring seamless player onboarding. That crucial initial experience where a new player learns the ropes without feeling overwhelmed, confused, or lost. If onboarding fails, you lose players immediately.
So they're not just designers, they're part psychologist, part detective, part teacher, part problem solver.
In many ways, yes. Absolutely. Beyond pure design skills, game UX designers need a deep understanding of player psychology, motivation, and behavior. They rigorously use all those feedback channels we mentioned, interviews, surveys, forums, testing to gather both qualitative insights, why players feel something, and quantitative data, how many players encounter an issue.
And ultimately, this focus on UX can make or break a game.
It really can. The effectiveness of game UX often determines a game's success or failure in the market. It significantly influences player reception, engagement, reviews, word of mouth, and long-term retention. It's one of the most foundational aspects, and without good UX, even a game with a brilliant concept or amazing art can ultimately fall flat because it's just not fun or intuitive to play.
Okay, so this game development journey is clearly a massive undertaking, far more than just coding and drawing. You described it as a multidisciplinary practice earlier.
Absolutely. Think of it as this complex blend of art and science. It's a true fusion of creative vision and really rigorous technical execution. It involves this wide array of specialized skills.
Like what specifically? Let's list some core ones.
Okay, you've got programming, obviously, to build the core functionality, the systems, the AI, then intricate design work to craft the gameplay loops, the level layouts, the player progression systems. You have various artistic disciplines, 3D modeling, character animation, environment art, visual effects.
The visual side.
Huge part. Then audio specialists for immersive sound design, sound effects, and compelling music scores. User interface designers focusing just on the menus and HUDs. Dedicated writers crafting compelling narratives, dialogue, world-building lore.
Wow.
And all of this is supported by crucial behind-the-scenes roles in project management, production to keep things on track, and quality assurance, the testers.
That's a huge list of roles.
Yeah.
What do typical development teams actually look like? Is it always a massive studio with hundreds of people, or can it be much smaller scale?
Oh, it varies dramatically. Teams can range from literally a single person, the solo indie developer pouring their heart into a passion project, to hundreds, sometimes even over 1,000 employees for a massive AAA title like a Grand Theft Auto or Call of Duty.
So huge range.
Huge. Wikipedia notes that while specific job titles might vary a bit between companies, the core roles remain remarkably consistent across the industry. Artists are often the most represented specialists numerically.
More artists than programmers.
Typically, yeah. Followed closely by programmers, then designers, and finally, audio specialists. You'll usually have maybe 1 to 3 producers managing the overall project, handling the logistics, budget, schedule.
And writers, testers.
Many teams, especially for larger games, include dedicated writers. And part-time testers are incredibly common, especially towards the middle and end stages of development. QA is essential.
So it's not always about having all those hundreds of people sitting in the same building, right?
Yeah.
I imagine outsourcing plays a big part, especially for managing costs and accessing highly specialized skills that might not be needed full-time.
Outsourcing is very, very common, particularly for disciplines that are needed for maybe shorter, intense bursts during development or require extremely niche expertise that's hard to maintain in-house.
Like what kind of roles?
High-quality audio production is a big one, composing original scores, recording professional voice acting and dialogue. Motion capture is another frequently outsourced task. Employing dedicated staff and facilities for these full-time can be incredibly expensive.
Yeah, you don't need a mocap stage running constantly.
Exactly. Outsourcing plans are often conceived way back in the pre-production stage to accurately estimate the time and finances required. We saw that figure earlier. High-quality synthesized music could cost $600 to $1,500 per minute back in 2003. Bespoke sound effects are also often sourced externally. And increasingly, even some programming work gets outsourced to manage costs or access specific technical skills, maybe for porting a game to a new platform.
And I've heard this term ghost development used sometimes in this context. What does that actually mean?
Yeah, ghost development. That's where outsourced work sometimes goes uncredited on the final product. This might be against the wishes of the contracted developer, or they might reluctantly consent to it just to get the work.
So the people who did the work don't get named.
Sometimes. But it can also be a deliberate agreement. The outsourced party might prefer anonymity, or the hiring company insists on it to protect their own brand equity.
Hmm.
Companies might not want consumers, or more importantly, investors, to know they rely heavily on external help, maybe even for entire games in some cases. It maintains that image of self-sufficiency.
Interesting. A bit hidden. Okay, let's talk about the actual development pipeline itself. Taking a game from just an abstract idea to something real, playable. Where does it all begin on that timeline?
It always starts with pre-production. This is essentially the meticulous planning phase. It's where the core idea and concept are really developed, refined, and documented. This leads to a suite of initial design documents.
Documents are key here.
Absolutely. The goal is to produce clear, easy to understand documentation that outlines all the tasks, the proposed schedules, the budget estimates for the development team. Publishers, especially, often require broad game proposals, maybe even playable prototypes, before they'll even consider funding a project.
So it's about minimizing risk before committing huge resources.
Precisely. Laying out the blueprint before you start digging the foundation.
What kind of documents are we talking about here specifically? How detailed do they get?
There are usually a few stages. It often begins with a high concept. This is just a brief, maybe one or two sentence description answering that fundamental question. What is your game actually about? It's the elevator pitch. Short and sweet.
Simple, yet probably crucial for getting everyone on the same page quickly. Just conveying the core essence.
Exactly. It crystallizes the idea. Next, there's usually a pitch or proposal document. This is a short, compelling summary. It highlights the game's unique selling points and explains why it would be profitable to develop. Why should someone invest in this idea?
The business case.
Right. Verbal pitches are often made to internal management or potential publishers, frequently accompanied by early concept art or maybe very rudimentary demos to secure that crucial funding and buy-in.
Okay, makes sense. And then, assuming the pitch goes well, you dive deeper into the concept itself, fleshing out all the details.
That's when you get to the concept document, sometimes called the game plan or, more formally, the game design document, GDD, although full GDDs often evolve throughout development. This concept doc is much more detailed than the pitch.
What goes in there?
It comprehensively covers pretty much everything. The high concept, again, the genre, a detailed description of the gameplay mechanics, core features, the setting, the story outline, the target audience, the intended platforms, PC, console, mobile, an estimated schedule, maybe a marketing analysis, team requirements, and crucially, a thorough risk analysis. What could go wrong?
Planning for problems.
You have to. And even before this full concept document is approved, often a skeleton crew, maybe a couple of programmers and artists, begins working on quick prototypes and concept art, just to visualize key elements and test core assumptions early on.
Prototypes sound really important throughout this. Are they always actual mini-games, or can they be simpler?
They're not always fully fledged minigames, especially early on. Prototypes are absolutely crucial for rapidly testing gameplay ideas and features before you invest heavily in building them out fully. They can be done manually very early on. Paper prototyping.
Paper prototyping, with actual paper.
Yeah, using paper, dice, cards, whatever works. It's incredibly fast for testing and iterating on core mechanics, rules, game flow, before you even write a line of code. Or they can be digital prototypes, often developed very quickly with minimal art or polish, just to prove a concept works or test a specific technical feature, like a control scheme or an AI behavior.
So the goal is quick learning.
Exactly. They allow developers to add, modify, or just throw out features rapidly. It ensures the core ideas are fun and functional before extensive, expensive development begins. It's all about failing fast and cheap to find what actually works. Iterate quickly.
Okay, so once pre-production's done, the plan is solid, the prototypes look promising. You move into the main event, production. What happens here when the full team really kicks into gear and starts building the actual game?
Right, production. This is where the game truly takes shape and grows from those initial concepts and prototypes into the final product. Programming is obviously a continuous central process throughout this stage.
Writing the code.
Lots of it. Programmers develop the core systems, implement all the new features based on the evolving design document, integrate the art and audio assets, and are constantly fixing bugs. Even if you're using an off-the-shelf game engine like Unity or Unreal.
There's still custom code needed.
Always. Extensive customization is always required. You need a lot of bespoke coding to achieve the unique vision, the specific mechanics, the feel of your particular game. Engines provide a foundation, not a finished house.
I can only imagine how complex that must get. with potentially millions of lines of code all needing to interact seamlessly without breaking. What about building the actual game environments, the levels the world's players explore?
That's level creation. And here's something that often surprises people. The very first level of a game frequently takes the longest to develop.
The first level takes the longest.
Right. Yeah, sometimes over 12 months for a 3-year project. It's not just because it's the first one you build. It's because the level designers and artists are often simultaneously using, testing, and refining the in-house tools and workflows for building levels while they're building that first level.
Ah, so they're building the tools and the level at the same time.
Pretty much. Plus, the game's vision might still be evolving. New features get introduced during development that might require older levels to be reworked or even scrapped entirely. So early levels might get developed, refined, thrown out, and rebuilt multiple times.
That sounds potentially frustrating.
It can be, but it's part of the process. Later levels, however, are typically developed much faster and more efficiently. By then, the tools are mature, the workflows are established, the core mechanics are locked down, and the overall game vision is clearer and more stable.
That's a really interesting insight. I would have thought the later levels, maybe with more complex mechanics introduced, would take longer. And then there's the sound, audio, which can truly make or break a game's atmosphere and player immersion.
Oh, absolutely critical. Audio production covers everything audible. That includes creating all the sound effects and composing and implementing the game's musical score.
Sound effects seem really important for feedback too, right?
Hugely important. They cover everything from realistic in-game sounds, footsteps, weapon fire, environmental noises, to really subtle but vital UI sound design. Those little clicks and beeps that provide critical auditory feedback for player interactions, like navigating menus, confirming selections, or picking up items. They make the interface feel responsive.
And the music sets the mood.
Totally. Music can be synthesized digitally or performed and recorded live, sometimes with full orchestras for big AAA titles. And as we touched upon earlier regarding outsourcing and cost, high-quality synthesized music alone could cost hundreds, even thousands of dollars per minute, even back in 2003. It highlights the significant investment required for professional audio, an area that's often underestimated by outsiders but is crucial for immersion.
It's crystal clear that successful game development isn't just about creative genius or technical skill. It's heavily reliant on effective project management. How do teams, from tiny solo developers to massive studios, keep everything organized? How do they ensure such a complex symphony of tasks, dependencies, and people actually comes together?
Project management is absolutely essential. It's the glue holding it all together. Many teams, regardless of size, adopt Kanban-style boards these days.
Kanban, right, like Trello.
Exactly. Trello, Plan, Jira, Azure DevOps boards, they're all examples. These are highly visual workflow management tools. They typically feature columns like to do or backlog, ready to begin, in progress, or doing and done. Sometimes more complex columns for review or testing stages.
And you move tasks across the board.
Yep. This simple visual system helps the entire team track progress easily, identify bottlenecks like if the doing column gets overloaded, and it often helps limit the number of tasks in progress simultaneously, which fosters focus and reduces context switching.
So it's about breaking down that proverbial elephant, building the game into manageable bites, and keeping a clear eye on where everyone stands with their piece. What other kinds of tools are developers using for managing their projects? The Reddit game dev communities had some fascinating practical insights here.
Yeah, those Reddit discussions provided a great ground-level view of the diverse tool chains developers actually employ. For code repositories, which are fundamental for team collaboration on code.
Where the actual game code lives.
Right, where they store it, manage different versions, merge changes from multiple programmers. Common choices there are GitHub, Gitea, GitLab, Bitbucket. These are absolutely critical for enabling multiple programmers to work on the same code base simultaneously without constantly overwriting each other's work. Version control is non-negotiable.
Makes sense? And for brainstorming and just general knowledge sharing, given the sheer volume of ideas, decisions, and documentation involved in making a game.
Good point. For brainstorming and building shared knowledge bases, developers mention tools like Miro for visual organization, like collaborative online whiteboards. U-Track came up, often used for managing bug tickets, but also serving as a central knowledge repository. And even ubiquitous tools like Google Docs and Sheets are widely used for design documents, spreadsheets, tracking assets, detailed planning.
Any more specialized tools for that?
Yeah, some mentioned Obsidian for creating complex flowcharts, visualizing intricate game systems, or narrative branching. And things like DokuWiki for building comprehensive, searchable internal wikis for the project documentation. Keeping everyone informed is key.
And it's not just about tracking what's being done, but also ensuring the quality of the code itself, right? Automating some checks.
Right. This is where automation comes in. For build automation and static code analysis, tools like TeamCity or Jenkins and SonarQube are used. TeamCity might be set up to automatically compile the game and run automated tests every time a programmer commits new code to the main development branch.
So catching errors early.
Exactly. And then it might send reports from those tests or code analysis tools to SonarQube. SonarQube analyzes the code for potential bugs, security vulnerabilities, code smells, basically, signs of poor quality code. It can even be configured to automatically create new bug tickets back in a system like UTrack for any issues it finds.
Closing the loop. Nice.
Yeah, it creates this automated quality control feedback loop, keeps the code base healthier.
And for just keeping the team connected, especially if they're distributed across different locations or working remotely.
Communication tools are vital. Discord is hugely popular for quick text chats, voice calls, and community building within the team. Some larger teams, interestingly, still use traditional forums like PHPBB for more elaborate threaded discussions, maybe for detailed design proposals or long-term planning topics where you want a persistent record.
Different tools for different communication needs. What about time tracking? Does that actually help?
Some teams find it very useful. Clockify was mentioned as a tool to track how long each task actually takes compared to the initial estimate. This is crucial for improving future project scheduling, understanding where the bottlenecks are, and also for helping prevent developer burnout by making workloads more visible and realistic.
Aligning estimates with reality. Good idea.
Yeah. And for UI/UX design, specifically for creating interactive prototypes of interfaces, Penpot was highlighted as a collaborative, open-source design tool.
So it's clearly far more than just a glorified to-do list, as one Reddit user humorously put it. This whole ecosystem of tools helps manage the inherent chaos of game development.
That's a crucial point. That Reddit comment was spot on. While these tools manage tasks, effective project management goes way beyond just ticking off items on a list. It's about meticulously managing dependencies between different parts of the game. Ensuring the 3D models are ready before the animators need them, and the animations are integrated before the programmers can hook up the logic.
The domino effect.
Exactly. It's about making difficult trade-offs when resources are limited or time is short. Do we spend an extra week polishing this existing feature, or do we cut it to add a different one? It's about ensuring the entire team stays aligned on the creative vision and the technical execution, which can drift over long projects. And maybe most importantly, it's about fostering a productive, adaptable work environment where problems can be raised and solved quickly. Project management is truly the unsung hero that keeps a complex, multidisciplinary, beast-like game development from descending into chaos. It facilitates the continuous learning and adaptation of the team.
Now, as fascinating as the creative and technical aspects are, there's a whole other side that's absolutely critical, the business side. This includes the legalities, the marketing, how the game actually makes money. And you really can't talk about the business side without starting with intellectual property or IP. This is all about protecting that incredible creativity and hard work we just discussed.
IP is absolutely foundational to the game industry. You invest potentially millions, years of work you have to protect that asset. Trinity Jurix's Legal Guide to the Game Industry really stresses that IP ownership isn't automatic and needs to be explicitly defined in contracts.
So just hiring someone doesn't mean the company owns everything they create.
Not necessarily, no. Merely having an employment contract doesn't automatically grant full IP ownership to the employer in every single jurisdiction or for every type of creation. Explicit agreements spelling this out are vital. For example, the guide mentions that in some places, like Lithuania apparently, an employer's copyright for things other than computer programs might only last 5 years unless a contract specifically says otherwise.
5 years. That's really short for a game asset.
Right, and royalties might even be due for certain designs or inventions created by employees if the contract doesn't specifically address ownership and compensation terms clearly. So vague contracts are a recipe for disaster.
So, rule 1. Get watertight contracts that spell out exactly who owns what to avoid massive legal headaches and unexpected costs down the line, especially with employees.
Absolutely, and that applies equally, maybe even more so, when IP is created by third parties like that outsourced audio studio or a freelance character designer. Those contracts must clearly specify the scope of use. What can they do with the IP? The territory, where can they use it? The term, how long? the remuneration, and critically, who is liable if that third-party IP accidentally infringes on someone else's rights.
Oh, wow. Chain of liability.
Exactly. Failing to nail down these details can lead to legal presumptions under local law that are definitely not in the game company's best interest. For example, some laws might presume the right to use the work is limited to just a one-year notice period for termination, or maybe only usable within the specific country where the contract was signed, regardless of where the game is actually sold.
That could completely derail a global game release if you suddenly lose rights in key markets.
Devastating. Which is why precise, globally minded legal agreements are absolutely non-negotiable.
Okay, so that's ownership. What about trademarks? That's about protecting the game's brand identity, right? The name, the logo.
Exactly. Trademarks are essential for establishing and protecting a game's identity in the marketplace, distinguishing it from competitors. They can be words, like the game title, specific designs or logos, unique sounds, like a startup jingle, memorable slogans, or even moving images, like a distinctive intro animation.
Lots of things can be trademarked.
Yeah, and it's critical to conduct thorough trademark searches early in development to make sure your chosen name or logo isn't already similar to an existing trademark in your key markets. Finding this out late can force expensive rebranding or lead to costly legal disputes.
So checking early saves pain later. How does registration work? Is it country by country?
It generally needs to be protected, country by country, yes. But thankfully, systems exist to streamline this. You can file for national registration in just one country, which is usually cheapest if that's your only market. For broader protection, like across the European Union, a single regional application covers all 27 member countries.
Yeah, it's efficient.
Very. And for truly global reach, there's an international system, the Madrid Protocol, where one application can designate protection in up to 130 countries. Once registered, a trademark typically protects you against others using similar marks for comparable goods or services. Protection usually lasts for 10 years initially, but crucially, it can be renewed indefinitely as long as you keep using the mark and pay the fees.
So trademarks protect the brand. Then there's copyright, which seems to cover pretty much everything inside the game itself. The story, the art, the music, the code.
Copyright is incredibly broad, yes, because games are considered complex works of authorship containing countless distinct creative elements. All those things you mentioned, plots, character designs and backstories, musical compositions, sound recordings, visual art, animations, the text, the dialogue, they're all typically protected by copyright. And of course, the computer programs themselves, the source code, that's always copyrighted literary work.
Does copyright require registration like trademarks?
Generally, no. Unlike trademarks, copyright protection arises automatically the moment an original work of authorship is created and fixed in a tangible form, like written down, drawn, recorded, or saved as code. Registration can offer additional legal benefits, like making it easier to sue for infringement in some countries, but the basic right exists from creation.
Okay, now what about the elephant in the room? AI-generated content. That's a huge topic right now. Can AI creations be copyrighted? If an AI generates art or music for a game?
That's a key legal battleground right now, and the law is still evolving. But the current consensus in many jurisdictions, including the US, is that works created solely by AI without sufficient human authorship or creative control may not be eligible for copyright protection.
Because there's no human author.
Exactly. Copyright law traditionally requires a human creator, so game copyright as it stands fundamentally relies on the creative input of human beings. The producers, designers, artists, programmers, writers, audio designers, their creative expression is what gets protected.
So what kinds of things within a game are typically covered by human-authored copyright?
Oh, the list is long. The source material mentioned: musical compositions, sound recordings, voices, sound effects, photographic images used, moving images, cinematics, gameplay itself, animation, all the text, dialogue, item descriptions, lore, the primary game engines of custom-built, ancillary code, plugins, even code comments sometimes, the script, the plot, literary works within the game, developed characters, their appearance, traits, backstory, choreographies like specific dance emotes, pantomimes, maps, even architectural works designed within the game world.
Wow, okay. So pretty much every creative element a human touches and expresses tangibly.
That's a good way to put it.
And if you're using something you didn't create yourself, maybe licensed music or a character from another franchise, or even just a piece of third-party software, you absolutely need permission, right? Licensing.
Absolutely. This is called right clearance, and it's done through meticulously drafted licensing agreements. It's super common for games to incorporate third-party IP licensed music tracks are a classic example. Maybe using existing real-world brands or trademarks within the game, or even incorporating third-party hardware solutions or software libraries. You need explicit permission for all of it.
And licensing isn't just for using other people's stuff, it's also how you let others use your game, right? Like distributors.
Exactly. Licensing is also crucial for distribution and monetization. Agreements with platform holders like Sony, Microsoft, Nintendo, Steam, publishers, distributors, these are all licenses. Key considerations in any licensing agreement are always what specific IP is being licensed, what's the precise scope of its use, CAG promotion only, in-game only, what's the territory, how long does the license last, the term, what's the remuneration, flat fee royalty percentage, what are the conditions under which the license can be terminated, all need to be crystal clear.
Seems complex. What about open source licenses? They often seem free and easy to use, which must be tempting for developers looking to cut costs or speed things up.
They are very tempting and incredibly widely used in software development, including games. However, the sources strongly advise thorough research, ideally with experienced IP lawyers, before incorporating open source components, especially critical ones.
Why the caution, if they're free?
Because free doesn't always mean no conditions. Many open source licenses, even permissive ones, have specific obligations like providing attribution or including the license text. Some licenses, known as copyleft licenses, like the GPL, have more significant conditions. If you use copyleft licensed code in your game, you might be legally obligated to make your own game's source code publicly available under the same open source terms.
Wow, so using one free component could force you to give away your entire game's code.
It's a potential risk if not managed carefully. It can inadvertently cause developers to lose exclusive rights to their own creation. So, while open source is powerful, it's a potential minefield if you don't understand the specific license terms and comply with them meticulously. Expert legal advice is highly recommended here.
Okay, so protecting the game's IP is crucial. But then, studios need to actually get the game out there to players. Which brings us to marketing and advertising. This is absolutely vital for a game's commercial success and building its reputation, but like everything else, it comes with a lot of rules and regulations.
It really does. Fundamentally, advertising must always be decent, accurate, and clearly recognizable as an advertisement. It can't be disguised as, say, editorial content or user reviews if it's paid promotion.
What kinds of things are strictly off-limits in game advertising?
The Legal Guide to the Game Industry laid out a pretty comprehensive list of prohibitions based on typical regulations. Advertising cannot be surreptitious, hidden. It can't violate public morality or humiliate human dignity. It can't incite discrimination based on race, gender, religion, etc. It mustn't spread defamation or disinformation about competitors or anyone else.
Basic decency, mostly.
Right. It also shouldn't contain gratuitous violence or aggression unrelated to the game content itself. It can't encourage panic or promote behavior that's unsafe for health or the environment. It shouldn't abuse superstition or trust, or use people's names or images without their explicit consent. Using subliminal messaging is out. And of course, it can't violate copyright or other IP rights.
That's a lot of pitfalls to avoid. What about misleading advertising? That seems like a huge one, especially in an industry where hype often precedes the actual release.
Yeah.
Trailers showing things not actually in the game, for example.
Misleading advertising is strictly prohibited, yes. The key test is whether it misleads or is likely to mislead consumers in a way that affects their economic behavior, basically, making them buy something or spend time on something they wouldn't have if they had the accurate information.
How is misleading judged? It seems subjective.
It's judged against three main criteria, usually. Accuracy. Is the information factually correct and provable? Comprehensiveness. Is any essential information omitted or presented vaguely, like hidden costs or limitations? And presentation. Does the way the ad is presented, images, tone, comparisons, imply incorrect statements, even if the words themselves are technically true? If an advertisement fails on even one of these points, it can be deemed misleading. Using pre-rendered footage that looks way better than actual gameplay without clearly stating it, for instance, can be problematic.
Okay, that makes sense. What about comparative advertising? Directly comparing your game to a competitor's in an ad. Our RPG has 50% more quests than Game X. Is that allowed?
Yes, comparative advertising is generally allowed in many places, but again, with strict rules to ensure fair play. It's permissible if it's not misleading, if it compares goods or services that genuinely serve the same purpose, if it objectively compares one or more significant relevant, verifiable, and representative features like price, maybe technical specs, or specific content amounts. If it doesn't create confusion between the advertiser and the competitor, if it doesn't discredit or denigrate the competitor's trademarks or reputation unfairly, and if it doesn't unfairly leverage a competitor's established reputation or trademark.
So it has to be a genuinely fair, objective, and verifiable comparison, not just mudslinging.
Exactly. Stick to the facts, compare like with like, and don't be deceptive or unfair.
And a special note on advertising directed at children. That feels like a particularly sensitive area that requires extra care and has specific rules.
It absolutely is. There are special protections for children due to their potential vulnerability and lack of critical judgment. Advertising is strictly prohibited if it abuses children's trust or takes advantage of their inexperience. It shouldn't suggest that using a product gives them a social advantage, makes them cool, or implies they'll be inferior if they don't have it. It also shouldn't unreasonably show children in dangerous situations.
What about targeting ads to kids using their data?
That's a big one now with data privacy laws like GDPR. Behavioral profiling for ads, where ads are targeted based on tracking a user's past online activity and inferred interests, should generally be disabled by default for users identified as children. The default should be non-targeted, contextual ads. It really highlights the significant ethical and legal responsibility developers and marketers have when their games or advertising might reach younger audiences.
Now let's talk about the elephant in the room for many game developers, especially larger ones: the costs. Development costs are notoriously high and seem to have been on a significant upward trajectory for decades now. It's truly escalating.
It really is. The costs vary wildly, of course, based on team size, the genre. An open-world RPG is vastly more expensive than a mobile puzzle game. The scope and amount of content, and any intellectual property licensing fees involved. Console games also have extra costs, like development licensing fees paid to platform holders, and the need for expensive hardware development kits, which can be thousands of dollars each.
But even accounting for all that, the general trend is sharply upwards, right? Especially for those big AAA games.
Oh, dramatically. The historical escalation is eye-opening. If you look back, prior to the 1990s, budgets for even major games were typically in the range of, say, $1 million to $5 million.
That seems almost quaint now, considering the figures we hear thrown around for modern blockbusters.
It really does. The big shift happened in the mid-1990s with the widespread adoption of 3D rendering technology and the storage capacity of CD-ROMs. This allowed for much more complex graphics, bigger worlds, and cinematic narratives. Budgets suddenly soared as developers invested heavily in these areas.
Any examples from that era?
Yeah, Final Fantasy VII in 1997 is a famous example. Its estimated development budget was around $45 million, but the total cost, including marketing, was reportedly somewhere between $80 million and $145 million. Shenmue in 1999 was even higher for its time, supposedly costing $47–70 million just for development. This period really marked the birth of the AAA industry as we know it, where these massive investments became the norm for flagship titles.
And it hasn't stopped climbing since then, has
Yeah.
it? This isn't just standard inflation. It seems like something more fundamental is driving it.
Not at all. It's continued relentlessly. Ralph Kuster, a prominent game designer and thinker, observed what he called Moore's Law of game budgets back in 2017. He crunched the numbers and found that average budgets for major games have essentially doubled every 5 years, even after adjusting for inflation since the mid-90s.
Doubled every 5 years. Wow. What's driving that exponential growth?
It's a combination of factors. It's partly driven by the sheer increase in computational power, Moore's law, for processors, which allows for exponentially more detailed graphics, physics, AI, larger worlds. But critically, it's also driven by rising player expectations. Gamers now expect incredibly high fidelity, vast amounts of content, deep systems, and hundreds of hours of playtime for major releases. Meeting those expectations requires bigger teams, more specialized roles, longer development cycles, and thus much higher costs.
So technology enables it and player expectations demand it.
Pretty much. By 2017, Koster noted average budgets for major titles were already hovering around $100 million. Sean Layden, when he was CEO of Sony Interactive Entertainment, even anticipated back then that flagship PlayStation 5 games could easily reach $200 million for development alone.
An astronomical figure for a single creative product. The scale of that investment is just staggering. And these numbers just keep going up, even since 2017.
It seems so. A 2023 report related to the Microsoft Activision Blizzard acquisition revealed further escalation. It suggested that typical AAA development costs had climbed from the $150 million range around 2018 to $200 million and significantly upwards by 2023 for top-tier titles.
$200 million plus, just for development.
Just for development, yes. Marketing costs can easily double that figure for a global launch. Some major AAA games have even reportedly exceeded $1 billion in total cost when you combine massive development budgets with equally massive global marketing campaigns. Recent concrete examples that came out in leaks included Sony's Horizon Forbidden West and The Last of Us Part 2, both reportedly exceeding $200 million in development costs alone.
That's truly mind-boggling. What's the implication of these constantly rising costs for the industry as a whole? It sounds like it would make publishers incredibly risk-averse, right? Sticking only to guaranteed safe bets.
That's precisely what happened, especially in the early to mid-2000s. The rapidly escalating costs of AAA development pushed major publishers to become much more conservative. They started heavily favoring sequels to already successful franchises or games based on established, popular IP, like movie licenses. Why? Because these were seen as the most likely to recoup those massive nine-figure investments and generate reliable profits for shareholders. Betting $200 million on a completely new, unproven idea became terrifyingly risky.
So fewer original blockbusters, more sequels and reboots.
That was the trend.
Yeah.
But interestingly, this risk aversion at the top end inadvertently opened a significant door for independent games to flourish in the mid to late 2000s. Because with the big publishers focused on safer, bigger bets, there was suddenly less competition in the space for more niche, experimental, or artistically daring ideas. Smaller indie teams, often self-funded or using crowdfunding or early digital distribution platforms, didn't have the pressure to achieve massive, multi-million unit sales to justify their much smaller budgets. They could afford to take creative risks, explore unique gameplay concepts, and experiment with innovative art styles that larger studios beholden to massive budgets wouldn't dare touch.
That's a fantastic insight, almost a paradox. The prohibitive cost and risk of AAA development inadvertently created the fertile ground for the indie renaissance. It really highlights how economic pressures can radically reshape a creative industry, sometimes pushing innovation into unexpected corners.
Exactly. It shows the dynamic interplay between economics, risk, and creativity in the game space.
Okay, let's shift from the costs of making games to how they actually make money, monetization strategies. And alongside that, consumer protection, especially given the rise of digital distribution, free-to-play models, and all sorts of in-game purchases.
This is a hugely important area, and one with increasing regulatory scrutiny worldwide. European Union regulations, for example, are quite stringent now. Companies selling games or digital content must provide incredibly clear and comprehensive pre-contractual and contractual information to gamers before they buy or even start playing.
What kind of information needs to be provided up front?
Pretty much everything critical to the decision. The main features of the game and its content, any age limits or ratings, the minimum system requirements to run it, the total price including all taxes, details of any recurring fees or subscriptions, clear and accessible refund policies, and the full terms and conditions of use, including, importantly, how automatic renewals for subscriptions work and how to cancel them. This information has to be easy to find and understand, not buried in legalese.
Transparency is key. What about once you've bought the game? What core rights do consumers have, especially with digital games where you don't own a physical disc?
Consumers still have several key rights designed to protect them in the digital marketplace. There's the right to access the games they've paid for. Without undue delay, they should be able to download and play reasonably quickly. They also generally have a right to withdraw from the purchase contract within a certain period, often 14 days in the EU, unless they've already started downloading or activating the game with their explicit prior consent and acknowledgement that they lose the withdrawal right.
So once you start downloading, you usually can't just change your mind for a refund.
Typically, yes, that's the trade-off for immediate access. But, crucially, consumers also have the right to conformity. This means the game must work as advertised, match the description given, and be fit for its intended purpose. If it's fundamentally broken or doesn't deliver on key promised features, consumers may have rights to repair, replacement, or potentially a partial or full refund. They also generally have a right to receive necessary updates, especially security updates, to ensure the game remains functional and secure for a reasonable period.
Okay. And age verification. That seems important for games with mature content or gambling-like mechanics.
Yes, age verification is crucial for games that have legal age requirements due to content, like violence or gambling themes. Companies need robust systems to check age where necessary, and clear disclaimers about age restrictions in their terms of use are essential to limit liability.
Now, let's talk about those controversial loot boxes.
Yeah.
They seem to be a constant source of debate and legal scrutiny, often drawing comparisons to gambling.
They absolutely are. Loot boxes, for anyone unfamiliar, are a type of in-game purchase where players pay real money, or sometimes in-game currency earned slowly, for a randomized bundle of virtual items. Could be character skins, weapons, power-ups, etc. The key is the element of chance.
You don't know exactly what you're going to get.
Right, and that random reward mechanism is precisely why they raise special legal considerations, because it can strongly encourage gambling-like behavior, especially among younger or more vulnerable players. The potential for addiction and overspending is significant.
Have regulators actually stepped in?
Yes, several countries have taken action. Belgium and the Netherlands, for example, have effectively classified certain types of loot boxes as a form of unregulated gambling, leading to major publishers removing them from games sold in those countries. Austria has seen similar legal challenges. The regulatory landscape is still evolving, but the pressure is mounting globally.
So what should companies using loot boxes be doing to mitigate risks?
They need to be very careful. They should assess the legal risks in all markets where they operate. Implementing robust age verification gates is a must. Clearly disclosing the odds of obtaining specific items before purchase is becoming increasingly expected, even legally required in some places. And ideally, implementing player-controlled spending limits or other responsible gaming features is advisable, both ethically and to preempt stricter regulation.
It's about responsible design and transparency. Makes perfect sense, especially protecting kids. And speaking of children, how does data protection, like GDPR in Europe, specifically apply to young players in the gaming world? Their data seems particularly sensitive.
It requires very special protection, yes. Under GDPR, children's personal data gets heightened safeguards. Any information and communication regarding data processing that's targeted at children must be exceptionally clear, concise, and simple to understand. Think age-appropriate language, maybe using visuals, short videos, or clear in-game pop-ups, because children may not fully grasp the risks or long-term implications of sharing their data.
So no dense privacy policies for kids.
Definitely not. Importantly, as we touched on with advertising, behavioral profiling for marketing purposes should generally be disabled by default for users identified as children. Companies shouldn't be tracking kids' behavior across apps and websites to target ads at them without explicit, verifiable parental consent, which is hard to get reliably.
What about things like collecting location data or analyzing gameplay habits?
Any processing of children's data, especially if it's high risk, like collecting precise location, extensive behavioral tracking, or direct marketing, may require companies to conduct a formal data protection impact assessment, or DPIA. This is a process to systematically analyze and minimize the data protection risks before they start collecting the data. It's all about implementing privacy by design and privacy by default right from the initial development stages of any game or platform aimed at or likely to be used by children.
Okay, moving beyond the game itself as a product, the connected digital world it exists in brings its own set of significant challenges, particularly in cybersecurity. And this is especially true for the booming world of esports, which relies entirely on stable, secure online platforms.
Cybersecurity is absolutely paramount in the modern gaming industry. It's not an optional extra, it's a fundamental necessity. Gaming companies handle and circulate truly vast amounts of sensitive personal data.
Like what kind of data are we talking about?
Everything from basic personally identifiable information, PII, like names, email addresses, dates of birth, to potentially sensitive financial data like credit card details used for purchases, communication logs, gameplay habits, friend lists, sometimes even location data. This wealth of data makes game companies incredibly attractive targets for cybercriminals.
What are the most common threats they face?
Oh, a wide range. PII leaks, where databases containing user information are breached and stolen, are unfortunately common. Sophisticated phishing attacks targeting players or even employees to steal login credentials or financial info. Distributed denial of service, DOS attacks aimed at overwhelming game servers and taking them offline, disrupting play for everyone. Malware distribution, sometimes hidden in game downloads or mods. and cheating tools or unauthorized game modifications that can exploit vulnerabilities to give players unfair advantages or compromise system security.
What's the real impact when a major breach happens? It's surely more than just a financial hit for the company, right? It feels like trust is the biggest casualty.
Far more than just financial, absolutely. While the financial damage can be significant, that think costs of remediation, potential lawsuits, and regulatory fines under laws like GDPR, which can be astronomical, up to 20 million or 4% of global annual turnover, whichever is higher, the most damaging and long-lasting impact is often on customer trust.
Why is trust so critical in gaming specifically?
Because gamers often invest heavily, not just money, but significant time and emotional energy in their online identities, their character progression, their achievements, their communities, and their virtual assets acquired over potentially years of play. A security breach that compromises their accounts, steals their virtual items, or exposes their personal information feels like a deep violation of that trust. It can cause irreparable damage to player loyalty and a company's hard-earned reputation. If players feel unsafe, they'll simply leave for a competitor's platform or game.
So robust cybersecurity isn't just good IT practice. It's a critical component of player retention, community health, and ultimately brand survival in the games industry. What concrete measures should companies be taking to protect themselves and, more importantly, their players?
They need a multi-layered approach, investing in robust security controls throughout the entire game lifecycle, from the earliest design phases right through to ongoing live operations. This includes secure infrastructure. Databases must be encrypted, networks and servers properly secured and hardened against attack, and effective DDoS protection implemented to ensure service availability, especially for online games.
What about the game software itself?
The game client, what runs on the player's device, and the back-end servers must also be built securely. This means adhering to secure coding practices from the start, performing rigorous input validation to prevent common exploits like SQL injection, implementing strong authentication, like multi-factor authentication, and authorization measures to ensure only legitimate users can access accounts and data.
So it's about being proactive in design and development, not just reactive after an attack happens.
Exactly. Being proactive is key. This includes conducting regular security audits and penetration tests, essentially hiring ethical hackers or using internal teams to actively try and break into your own systems to find weaknesses before malicious actors do. Companies also need a well-rehearsed incident response plan for when breaches inevitably occur. How do you detect, contain, eradicate, recover, and communicate?
What about monitoring the live game?
Continuous game monitoring in production is vital. Using specialized SIEM security information event management tools helps aggregate and analyze security logs from across the entire infrastructure in real time. This allows teams to spot potential security issues or ongoing attacks as they happen and respond quickly using dynamic alerting. And underpinning all this should be a comprehensive, documented cybersecurity strategy treated as a living internal document that evolves with the threat landscape.
And one last point on security.
Player education. Especially since many gamers are young and might have a limited understanding of complex security practices. Educating players on things like choosing strong, unique passwords, recognizing phishing attempts, being wary of unofficial downloads or cheats, that's an important part of the ecosystem's overall security posture.
Okay, now let's talk specifically about esports. It's just exploded in popularity over the last decade or so, becoming a massive global phenomenon with professional leagues, huge prize pools, millions of viewers. But being so new and digital native, it must come with its own unique set of legal and structural complexities.
It absolutely does. Esports is a rapidly growing, multi-billion-dollar industry, but its legal framework is still developing and often catching up to the pace of growth. There are lots of unique legal issues.
Where does the money primarily come from in esports?
A principal revenue source is endorsements and sponsorships, just like traditional sports. These can involve endemic brands, companies directly related to gaming, like computer hardware manufacturers, peripherals makers, energy drink companies often fall here.
Brands in the scene.
Right. And increasingly non-endemic brands, companies from outside gaming, like car manufacturers, fashion labels, fast food chains, are pouring money into esports sponsorships to reach that coveted young demographic. These deals can be incredibly complex, involving millions of dollars, exclusivity clauses, and detailed requirements for players and teams regarding brand promotion.
And players themselves often have restrictions.
Yes, players are often restricted by their team agreements from displaying or promoting competing brands during streams or tournaments. This creates these intricate marketing landscapes where teams, leagues, and individual players all have overlapping, sometimes conflicting obligations.
What about the gamers themselves, the pro players? How are they typically classified legally? Are they employees of the team, independent contractors, something else?
That's a really key legal question, and honestly, it's quite varied and often unclear depending on the jurisdiction. Professional esports players are typically contracted to teams, receiving salaries, benefits sometimes, and shares of prize money or bonuses. However, the precise legal qualification of their remuneration and status, are they employees with full labor rights or are they independent service providers, varies significantly by country and depends on the specific nature of the contract and the working relationship.
So it needs careful legal review.
Absolutely. The source guide mentions, for instance, that under some national laws, like Lithuania's, a careful case by case evaluation of each player's relationship with their team is required to assess potential labor law risks, like misclassification, and the correct tax implications. Lawyers specializing in both employment and contract law are pretty essential here to navigate these nuances correctly.
And cheating, which is unfortunately a reality in any competitive endeavor, whether it's through software hacks, match fixing, or other means. How is that handled legally in the esports world?
Cheating is treated as a very serious offense, as it undermines the integrity of the competition entirely. Consequences can be severe, ranging from automatic forfeiture of winnings and matches, lengthy or permanent bans from participation, heavy fines imposed by leagues or tournament organizers, and in rare extreme cases, particularly if significant fraud or illegal gambling is involved, even criminal prosecution is possible.
So leagues need strong anti-cheating measures.
Definitely. Esports leagues and tournament organizers need clear, predefined sanctions for various offenses, robust codes of ethics that players agree to, and well-defined, fair decision-making processes for investigating allegations and imposing punishments. Ensuring these rules are legally sound, fair, and enforceable often requires significant legal advice.
Given the truly international nature of top-tier esports, with players and teams from all over the world competing in global tournaments, I imagine there are major logistical challenges with things like visas and international tax implications, too.
Huge challenges. Before any international tournament, teams face the complex process of ensuring all their players have the appropriate visas for entry into the host country. This can be surprisingly difficult, as many countries don't yet have specific visa categories designed for esports competitors, leading to uncertainty and potential denials.
And the prize money. Taxed where?
That's the other big headache. Assessing the taxability of player earnings salaries, prize money, sponsorship income requires careful analysis. Is it taxable primarily in the player's home country, in the country where the tournament took place, or potentially both, requiring mechanisms to avoid double taxation? This requires upfront and accurate analysis by international tax specialists to avoid significant financial penalties for both the players and their organizations.
And structurally, we're seeing a lot of consolidation in the esports space recently, right?
Hmm.
Teams merging, leagues being bought, organizations acquiring others.
Yes, definitely. Mergers and acquisitions, M&A activity is ongoing and seems to be accelerating as the industry matures and tries to professionalize further and find sustainable business models. Valuations for top esports teams and league franchise spots can be incredibly high, sometimes hundreds of millions of dollars. Major stakeholders, venture capital firms, traditional sports team owners, media companies are buying teams or league slots to maximize their viability, consolidate market share, and expand their marketing reach. It's a clear sign of the industry's rapid growth and the increasing financial stakes involved, mirroring consolidation patterns seen historically in more traditional sports leagues.
It's really fascinating how much legal detail and structure goes into protecting everyone involved, creators, players, teams, businesses, in these complex and rapidly evolving digital ecosystems. And our sources specifically mentioned Lithuania's role in some of these legal frameworks, offering an interesting specific example of how some jurisdictions are trying to incentivize game development locally.
Yes, the legal guide to the game industry source we used frequently referenced Lithuanian law as a specific example when discussing general principles around IP, consumer protection, advertising rules, and data protection. It offered concrete examples of how these legal concepts are applied in one particular EU jurisdiction, and it specifically highlighted that game developers operating in Lithuania can benefit from some quite attractive tax incentives.
What kind of incentives?
Apparently, there's a potential 0% corporate income tax, CIT rate, for the very first year of operation for new companies. And after that, a significantly reduced rate of just 5% CIT might apply for small companies that meet certain criteria specifically, having fewer than 10 employees and under EUR 300,000 in gross annual revenues.
5%. What's the standard rate?
The standard corporate income tax rate in Lithuania is 15%. So going from 15% down to 5% or even 0% initially is a substantial incentive designed to attract and support small game development startups.
So tax policy can make a real difference in where studios choose to set up shop, especially smaller ones.
It can be a significant factor, yes. The guide also noted that while license fees paid to Lithuanian companies are generally subject to that standard 15 per CIT, Lithuania has an extensive network of double taxation avoidance agreements with many other countries. This helps prevent income being taxed twice if generated internationally, making it an even more appealing jurisdiction for international game development operations and attracting foreign investment into the local games industry. Small policy details can have big impacts.
Finally, just briefly, what happens when disputes inevitably arise in this complex, fast-moving industry? If there's a contract violation or an IP infringement or a consumer complaint, how are these typically resolved and who handles them?
It really depends on the nature of the dispute. The resolution path varies. For instance, complaints regarding misleading advertising or violations of consumer rights might be handled by specific supervisory authorities, like a state consumer rights protection service mentioned in the Lithuanian context.
So dedicated consumer bodies.
Right. Data protection violations, like a data breach or misuse of personal data, would typically be investigated and potentially fined by the relevant National Data Protection Authority, like the State Data Protection Inspectorate in Lithuania. They can act on their own initiative or respond to direct complaints from individuals.
What about IP disputes, like trademark infringement?
Trademark disputes might initially go through administrative channels at the National Patent Office or Intellectual Property Office, which handle registration and opposition proceedings. For more general commercial disputes, say, a breach of contract between a developer and a publisher, or a disagreement over royalty payments, these typically follow the general commercial dispute resolution rules of the relevant jurisdiction. That could involve negotiation, mediation, binding arbitration, or ultimately traditional court litigation. So there are established, often specialized channels for addressing the various types of conflicts that can arise across the industry.
Wow. We have gone on quite the journey today. From the digital blueprints of game engines and the really nuanced art of UX design,
Right.
through the complex dance of development teams and project management, the absolutely essential legal frameworks covering IP, advertising, consumer rights, all the way to the high-stakes world of esports and the ever-evolving cybersecurity challenges.
It really underscores that creating a video game is so much more than just, writing code or drawing nice pictures. It's truly a multidisciplinary symphony. It requires deep technical mastery, sure,
Hmm.
but also creative vision, keen business acumen, a profound understanding of human psychology and behavior, and a constant awareness of legal and ethical responsibilities.
Absolutely. And for you, the player, hopefully this deep dive shows that every click, every achievement unlocked, every moment of frustration or joy you experience in a game, it's all built on these incredible layers of intricate planning, countless decisions made by dozens or hundreds of people, and this constant effort to balance innovation with stability, creativity with compliance.
It definitely gives you a new appreciation for the digital worlds we inhabit, just knowing the sheer scale of effort and diverse expertise that brings them to life behind the scenes.
So, thinking about the future, what does this all mean? As game development costs continue to just skyrocket, especially at the AAA level, and as AI's role in content creation becomes more prominent, maybe even generating entire game assets or dialogues or level layouts someday, how might the landscape shift for both those massive AAA studios and the independent developers?
That's the billion-dollar question, isn't it?
Right. What unseen legal battles over AI-generated IP or new technological hurdles around managing even more complex productions might be shaping the next generation of games you love to play? It's definitely something interesting to consider the next time you pick up your controller or load up your favorite game.